In this video, we're going to have a look at how to write formulas for ionic compounds. And specifically, we're going to look at binary ionic compounds. What does binary mean? It simply means there's only two elements involved in my compound. So let's start off with taking some metal ions that we're going to use. Let's perhaps first take sodium. Sodium's in group 1. It loses one electron, so we'll form an ion with one positive charge. Let's take magnesium, group 2. It's got two valence electrons, so we'll lose both of those and become an ion with two positive charges. And aluminium, which is in group 3, is going to end up as an ion with three positive charges. For our negative ions, or anions, let's take fluorine first of all. That forms the fluoride ion with one negative charge. The oxide ion has two negative charges, and the nitride ion has three negative charges. So we're going to try some different combinations of these positive and negative ions and work out how to write the formulas for the resulting compounds. To do so, let's introduce a little table here to keep things nice and clear. And what I'm going to include at the bottom are some little blocks which are going to represent the charges on my ions. So to start with, let's take a nice simple one. Let's take the sodium ion and the fluoride ion. Sodium ion has one positive charge, fluoride ion has one negative charge. So the key when trying to work out the formula for ionic compounds is we need to have enough of each ion so that the charges cancel out in total, meaning my resulting formula is neutral overall. So if I do that on my little scale on the right hand side, sodium's got one positive charge, so there's one block representing that, and my fluoride ion has one negative charge, and you'll notice once I've added those two next to each other, we actually have equal amounts of positive and negative charge. And what does that mean? Well, that means in my formula, my ionic compound is going to have one sodium and one fluorine. Now you could technically write a little 1 and a little 1 there, but normally if there's just one of them, we don't write anything. So that's a nice easy example. Let's try a slightly more complicated one. Let's go for perhaps sodium and oxygen. So let's add my oxide ion in there. It's got two negative charges. And this time, if I add my charges to the scale on the right side, that's a sodium ion. It's got one positive charge. My oxygen or oxide ion has two negative charges. And you'll see that those charges there are not balanced. So how can I balance them? Well, all I need to do is take one more sodium ion, stack that on top, and I now have equal positive and negative charges. So in my formula, slightly different to the first example, I'm going to need this time two sodiums, so I'll put a little 2 after the sodium, and just one oxide ion, something like that. That would be sodium oxide. Okay, let's try another one. Move those back. Let's take sodium and the nitride ion. Nitride ion has three negative charges. So again, if I use my little scale, let's take my one sodium. Nitrogen has three negative charges. And you can see at this stage, the charges are definitely not balanced. So what do I need to do? Well, I can take another sodium ion. And in fact, that still hasn't balanced my charges. So I need to take one more sodium ion. And now we can see we have equal numbers of positive and negative charges. And what have I had to do to get there? Well, I've got three sodium ions. So I put a little 3 after the sodium and just one nitride ion. And that's my formula for sodium nitride. Okay, let's take a different metal ion this time. Let's start with magnesium, which has two positive charges when it forms an ion. And let's start with fluorine again, one negative charge. So same process, let's use my little charge blocks down here. I'm going to take a 2+ block because magnesium's got two positive charges. I'm going to take a 1 negative box for my fluoride. No, yet looks like my charges are not balanced, so what do I need? I need another fluorine, stack that up on top, and now I've got equal numbers of charges on each side. So what have I had to do to get there? Well, I've got one magnesium and I've needed 2 fluorines. So after my fluorine, I'm going to put a little 2 down there. Okay, let's change my negative ion, my anion. Let's use the oxide ion this time, O2 minus. And again, magnesium ion's got 2 positive charges, and my oxide ion's got 2 negative charges. So in this case, a nice easy one for us. We've already balanced the charges with just 1 of each. So my formula is going to be simply MgO. Okay, let's try one more like that with magnesium. Let's take magnesium and the nitride ion, N3 minus. What do I need to do now? Well, again, my magnesium ion's got 2 positive charges. My nitride ion's got 3 negative charges. They're not balanced. I've got less positive charges than negative charges. So if I take another magnesium, stick that on top, we've actually now got too many positive charges. So let's try taking another nitrogen. Oh, now I've got too many negative charges again. So how about if I take one more magnesium? And by doing that, I've actually now reached 6 positive charges in total and 6 negative charges in total. So in this case, it's a little bit more complicated. I've needed 3 magnesiums and just 2 nitrogens. So my formula for magnesium nitride is going to look something like that. Okay, let's try aluminium now and some combinations there. Let's start off with aluminium and the fluoride ion. 1 negative charge. Use my little blocks again. The aluminium has 3 positive charges. My fluoride's only got 1 negative charge. So it's definitely not balanced charges there. Let's take another fluoride ion. No, still not balanced. Let's take one more. Beautiful. So by taking 3 fluorides and 1 aluminium, I've balanced my positive and negative charges. So what's the formula going to be? It's going to be AlF3. That's aluminium fluoride. Okay, let's try aluminium and perhaps the oxide ion. So we've got O2 minus. Let's use my blocks again. Aluminium's got 3 positive charges. Oxide's only got 2 negative charges, so we're not balanced there yet. Let's add some more negative charges. Now I've got more negative charge than positive charge. So let's add another aluminium. Now I've got more positives than negatives. However, if I add 1 more oxide, beautifully, now we've achieved equal positive and negative charges. So what's my formula in this case? It's going to be Al2O3. That's aluminium oxide. And that's pretty much it for the understanding. We're always trying to find the number of each ion so that I've got the same total number of positive charges as I do negative charges. Now there is a little shortcut which I'm going to show you now, which is going to speed things up, but you need the understanding first of all. If I write my formula again in there, it was Al2O3. What I've actually done here, which is a simplified mathsy way of working this out, well, if I write my 2 ions up here, Al3O2 minus, I've actually just swapped the number of charges on each ion and given it to the other element to give me Al2 and then O3. So I can do that little swap version. Let's try it with another example. Let's get rid of those, get rid of that, get rid of that. Let's try, let's go for magnesium and fluorine, Mg2 plus, F minus. We said the formula for that was MgF2. Does that work in my shortcut? Well, if I take my Mg2 plus and my F minus and I switch the number of charges, so my 2 plus, or 2, goes down after the fluorine and the 1 negative goes down to my magnesium, I've got 1 magnesium, 2 fluorines. In this case, we can ignore the 1. MgF2 gives me exactly the same formula. Now there's one little complication just to be aware of. So if I take, let's go for aluminium, it's got 3 positive, the nitride 3 negative. my formula there is going to be AlN. Now if I apply my shortcut to this example, Al3 plus N3 minus, if I switch the numbers down to the opposite element, I would end up with Al3 N3, which is slightly different to the formula we wrote down here. Now the important thing to do in this case, if you're using the shortcut, if I get numbers that can be simplified, then I must simplify them. So if I divide both of those numbers by 3, I'm going to get Al1 N1, which actually, ignoring those ones, does now give me the formula we're looking for. And that's pretty much it for ionic compounds. Hopefully this video was of some help.